Welcome back. It's time for us to take a new topic in hand. Time to start with what is really the last major set of topics we have in this course, which is now moving away from the standard Cartesian plane and your standard functions f of x or y is equal some function in x. And we're going to start looking at everything through a different set of eyes. Well, I guess our same eyes, but just doing things a different way. You see, we've pretty much reached the end of the immediate applications for your standard fare with your rectangular coordinates on your Cartesian plane. And so the time has come for us to see how else we can look at systems. And this is going to be very useful in admittedly limited circumstances, but in those circumstances very useful. And we'll see what I mean by that here in the next few videos. First of all, this is just what we have left for us now. Basically, polar systems and parametric equations. Now, polar systems is kind of a complete departure from the Cartesian plane, and parametric equations is actually a return to the Cartesian plane. However, we change up how functions are made. So we'll see that there towards the very, very end here. But for now, let's worry about polar systems and polar coordinates. It turns out that this is something that we have been subtly building towards all semester long. And I'll show you what I mean here in a second. Right? Remember from the very get-go, the unit circle. We could define a point on the unit circle as where we end up after we move t from our starting position counterclockwise. So moving t units on the unit circle gave us some terminal point, and the coordinates of that was given by cosine t, sine t. So here's our unit circle again, and we recognize that as we move around, we end up at some spot, and the amount we move around on determines where we end up. And of course, we can keep going more and more times around in either direction, but we see that every single point is generated by a single number, and that number is t. And so we go all around this unit circle. We have x, y coordinates actually just determined by one number. So with rectangular coordinates, that spot would require x, y, which is two numbers. But now we can do it in just one. We can do it with t, and that gives us both the x and the y coordinates. But that is if you are on the unit circle. What if we were on bigger circles or smaller circles? What if we were on a circle of radius r? Well, that then gives us, instead of cosine t, sine t, r cosine t and r sine t. Or in this case, right, for general angle theta, r cosine theta, r sine theta. And it's going to be the case now that when we do that, so again, here's our unit circle guy. But if we do that for arbitrary radius r, we can actually get every single place on the Cartesian plane. We can pick up every single point everywhere. Of course, if this r value extended further out, which obviously it could, just not by the limitations I have imposed on the graph here, we could keep going and pick up every single point that we could have on the Cartesian plane with just two numbers, r and t, or r and theta. And so the variables we could use now, instead of x, y, we could use r and theta, where r is the distance from the origin and theta is your angle of rotation. And that would pick up every single x, y point. And so that's what we're going to do now. Right? Whereas before, a point needed two variables, x, how far to the left or right, y, how far up and down. Now we can do it with r, distance from the origin, and theta, angle of rotation. That will get us every single point. So here's a few points. We'll start off with this. And we'll take the time to plot each of these. So let's see here. I need r equal to 1. Because my first point is of radius 1 and angle of rotation pi over 4. So radius of 1 And you'll see these lines in here, they actually denote your common nice angles. You see this one corresponds to pi over 6, this one pi over 3, and halfway in between is pi over 4. And so our first point at 1 comma pi over 4 is that right there. The next one is at 2 5 pi over 3. So radius of 2 there. And 5 pi over 3 corresponds to that spot right there. So 5 pi over 3 on radius of 2, that is our second polar point. Third point of interest is C at 1.5, angle of rotation negative 5 pi over 6. So 1.5 is how far we are from the origin. And negative 5 pi over 6 corresponds to starting here and rotating negative 5 pi over 6, ending us at 7 pi over 6 as well. So there is our third point. And the last point of interest is a little confusing because that is on a circle of radius negative 1.5 and angle of rotation is pi over 6. So what that means is instead of going out this way, we're going to go out in the negative direction. So let's see here. Pi over 6 would be that spot right there, but that's positive 1.5. So going pi over 6 on a negative radius would actually end us up right here again. And those are the 4 points we have going on here. So we have now a few things to note, right? Positive rotation, positive radius, that's pretty self-explanatory. Negative rotation, also pretty self-explanatory. And negative radius, again, behaves a similar way, right? The negative sign just denotes move the other way. Just go the other way. And so to recognize that, one way to kind of combat that is first do the rotation and then do the movement in the negative direction. But we see now also a couple of other things, not the least of which being there's infinitely many ways to describe the same point. Right, whereas before, this spot right here, whatever it was in rectangular coordinates, we now have infinitely many ways to describe it with polar coordinates. And that's fine, and actually going to be very useful for us when we get into polar functions. But what I want us to have right now is how do we make these points? What do they represent? Right, we're going from x comma y to r comma theta. What does the r represent? What does the theta represent? What do these points look like? So I want you to think about that for a while, and we will go from there. Because what we're going to do next, in the next video, is start to go back and forth. Suppose, for instance, I have a rectangular point, maybe 3 comma 4. Where is that in polar coordinates? And that's what we're going to look at in the next video. So that is it for now. I'll see you then. Have a good one.